This short video will be about radioactive decay. I'm going to do a brief introduction to the atom and the forces in an atom, and then go over some definitions that should help with some later videos. So if you get stuck at any point, you can pause the video or rewind and watch again. Here's a picture of an atom. The first thing I'm going to do is talk about the forces involved in this atom. Now, the first force we need to talk about is called the electrostatic force. And this occurs between charged particles. Anything charged particles. For example, in the nucleus, you've got two protons. They're the same charge, so they're repelling. Your two electrons, they're repelling because they're the same charge. But between the proton and the electron, there is an attraction there because opposite charges attract. And that force involved is the electrostatic force. Now, if you look in the center, those two protons should be repelling. There's two positives, they should repel. Now, they're not repelling. So there is another force which is holding them together. And this is called the nuclear strong force. Nuclear strong force, which is a lot stronger, obviously. And this happens between nucleons. So this is anything found in the nucleus. So the protons and the neutrons have a force acting on them, holding them together, and this is called the nuclear strong force. On your screen now are two pictures of an atom. On the right hand side is a small atom. This is actually helium, and it's made up of two protons and two neutrons in the nucleus with two electrons around the outside. Now on the left is a very large atom. Look at the center in the nucleus. You've got loads of protons and neutrons. You've got loads of electrons around the outside. Now the bigger the atom, the more likely it is to, it kind of spits out some radiation. So from the nucleus there, we might get some alpha coming out of the nucleus. And that's because it's just too big. You might also get some beta coming out. So this will be an electron coming out of the nucleus. Now that's really strange. It's an electron coming from the nucleus. It doesn't come from the outer electrons, it's from the nucleus. We'll talk about that in a later video. And the last one is we might get some gamma coming out of the nucleus. Now it spits it out. It's a random process. It randomly just spits it out. And the technical word for that is called decay. It decays. And the word for spitting out is emit. It emits, a bit like the sun emits light. This nucleus emits radiation, and we call that a decay. So we call it alpha decay, beta decay, gamma decay. Now normally it's when the nucleus gets too large, it becomes unstable. Unstable means it's not likely to stay there very long. It will change in some way. A bit like if you stack some plates. If you do 3 or 4 plates, you'll be okay. If you stack 100 plates high, eventually it might just fall over. That would be an unstable pile. Well, this is similar. The nucleus might stay there for a while and then all of a sudden fall down or spit something out or emit some radiation. Now, when it gets smaller, like that helium atom, we would call that stable. It will stay like that for 1 million years. And that's because it's quite happy to stay like that for a long time. Now, the next thing we need to talk about is once there's been a decay, it's quite useful to measure the amount of decays per second. Decays per second. And this is called activity. So the amount of decays per second, say it was giving off 2 alpha particles every second, 2, another 2, another 2, another 2. We call that the activity. And it's measured, the activity is measured in becquerels, capital B, little q. It's measured in becquerels. So if there was 2 decays per second, we would say that's 2 becquerels. If there was 10 decays per second, 10 alphas per second, we call that 10 becquerels. And if there was 100, it could be 100 becquerels. It could be less, it could be 1 every 10 seconds, say, and that would be 0.1 becquerels. So the number of decays per second is called activity, and it's measured in becquerels. So it's called activity, that is the number per second, and it's measured, the unit is in becquerels. And the equipment we use to measure this is called a Geiger Muller tube. So it looks like a tube, and you hold it up to your sample and you can detect the number of decays coming off your sample. And that's attached to a machine. We normally call that a Geiger counter. A Geiger counter measures the activity of a sample. So it might detect 3 or 4, 100 decays per second, and it will show that, and it will measure it, and you can measure your activity that. It's quite useful to see how radioactive your sample is. Pause the video now and see if you can remember these 3 definitions. The answer will be on the next slide. The electrostatic force is the force between charged particles. So if I have my helium atom, I'll draw it quickly here. We have 2 protons and 2 neutrons, and then 2 electrons around the outside. Anything charged, so between proton and proton, or proton and electron, or electron and electron, this force is called electrostatic. Now inside the nucleus they're repelling each other, and there is another force holding them together, pulling them in, and that's called the nuclear strong force. An atom is unstable when it's too large, so it emits ionizing radiation, either alpha, beta, or gamma, and eventually it will become smaller and become more stable. It normally keeps going until it becomes stable. Pause the video again and have a go at these definitions. The answers will be on the next screen. A decay happens when a particle is emitted from the nucleus. So that's either your alpha, your beta, or your gamma coming from nucleus, and that's called it has decayed. The nucleus has decayed. Activity is the number of decays per second, and it's measured in becquerels. So 5 decays per second would be 5 becquerels. And we use a Geiger-Müller tube to detect it, and that's attached to a Geiger counter. And your Geiger counter will be used to measure the activity of a sample. That's the end of today's lesson. If you got stuck at any point, you can pause the video or rewind and go and have another look.